All right. So let's just give ourselves a couple of labels in here to label these guys. So this is going to be rows and columns. So inside of this, well, let's give it the old college try and see what we can. Get to my text view. Let's go with this. And we're going to call this guy, this is rows. And then we'll put another one of those guys out there. Large text. And we'll call this guy columns. I thought there was a way to link the two. So there's those dudes. So here's my first text view. And we just need to set his gravity to, oh, no, that's not his gravity there. That's the gravity in here to bottom. Except we need to get that guy on the other side of the gap. Okay, then we need to make the gap a little bit narrower. Let's make it 15. All right, we're going to call that perfect. All right. So we have our rows and our columns. Let's make sure we give these guys the right name. So instead of input text field, we're going to call this guy rows TF. Yeah, don't ask this again. And then this guy is going to be called calls TF. Okay. And then our button here is going to be, generate matrix. Gen matrix button. Okay. Oh. Yeah, whatever. All right. So we're going to go ahead and generate that matrix for us now, and we're going to set this text view down here. We're going to say width. We should be able to fill parent width-wise. And then height, we're going to keep the, actually, can we fill parent? Yeah, we don't want that. Match parent? No. Let's try just 200. Let's. Good enough. All right, so this is what we're going to output it to. Where does that email dealy thing come from?
It's always there.
Is it there when the app runs?
Yeah.
Oh, that's part of the, I get it. That's part of the content thing here. If I go into the XML, actually it's not in there. It's in the content, or it's just in main XML. Here's the project. Activity main. It's got to be in this guy. Whoa.
You delete the important thing.
Floating action button. I think it's this dude. Yeah, okay, we got him gone. Okay, so we'll save that. And we'll move this guy. Oh, we'll say it's good. Okay, so we already have this guy set up as our output. We have the generate matrix. We have our two input boxes. So let's go and connect all those up now. So that's inside of, let's close that, and close that, close that. Go into main activity. So we no longer have an input TF. Now this guy is called rows TF. And then we have calls TF. All right, we have our output label. Great. And so this guy is going to be called rows TF. And the ID is rows TF. Now we're going to steal this. Calls TF. It's going to be calls TF. It's actually nice that it did update that. So we have our rows, we have our calls, we have our output label. Let's change the name of, let's call this guy generate matrix button clicked. Okay, copy that. Because now, and this guy's no longer, well actually we don't want any of this in here for right now. And let's go fix that in the content. So on click for generate matrix button. Is now that guy. Okay. And for right now, let's just write something in here just to make sure these guys are working. So let's go here. And we'll say this dot output set text. And we're going to set the text to this dot rows tf dot get text concatenated with an x concatenated with this dot calls tf dot get text. All right, just proving we read the stuff in and transferred it over. Let's just make sure that's all kind of working. Oh, good. Now we can get rid of that guy because we got rid of the action bar. All right, so we got this guy. So let's do 4 rows by 5 columns and hit generate matrix. We get 4 by 5. All right. So now let's actually generate our matrix and then have it show up down there. Okay, just as a text thingy. So we're going to store our matrix inside of a 2-dimensional array. Sound fair enough? With this many rows and this many columns. Okay. So globally here, I'm going to go ahead and give myself a private variable. So this guy's going to be, we're going to do just an integer array, right? So we'll have an integer array called the matrix. Okay. And then down here, so notice here that even though we have these kind of new things we're working with, these variables here are just like the kind of variables we usually have, right? Private variables inside of our class, nothing different. They just happen to have some new types, you know, edit text and text views and that kind of stuff. All right, this guy, even though we didn't write him, this is just the first place. This is kind of like main in our current program. Okay, this is where everything starts from our perspective, is inside of onCreate. Technically, there is a main method somewhere farther back behind this, but from our perspective, the first time we have any opportunity to do stuff is inside of onCreate, inside of an activity. So in our minds, think of this like kind of like our main. All right. Just do that. All right. So then down, when we click this button, we're going to go ahead and we're going to set that matrix up. So we'll say this dot the matrix is equal to a new integer array, and this is going to be rows by columns. So that's going to be integer dot parseInt this dot rows tf dot get text. And then I need one more of those, right? This dot rows. No, need one more. Well, let's just do this. Int rows. Ooh. Int rows is equal to this guy. Int, well, let's finish fixing this then. Percent this dot rows tf get text. Oh, problem is this. Oh, do we need to turn that guy? Cannot change editable to a string. So then we need to go dot toString. And then int calls is going to be calls tf get string dot toString. So that'll get our rows by calls. And then for right now, let's just go and fill that guy up with a bunch of ones. Just for right now. Okay, so we'll say for int I is equal to 0, I is less than this dot. Oh, I haven't actually. Yeah, I need to actually build this thing first. So this dot the matrix is equal to new integer array rows by calls, like that. So that'll fill that guy up. Oh. Fix it there. So we'll say this dot the matrix dot length I plus plus. Then inside of this we'll have a for int j is equal to 0. J is less than this dot the matrix at bucket I dot length j plus plus. All right, and then we're going to go ahead and say this dot the matrix at bucket I j is equal to a 1 right now. Huh?
Why not 0?
That's fine. You want zeros? Doesn't matter. We're just going to make it show up. We're going to randomize it here in a few minutes. Okay. All right. So that's what that guy's going to look like right now. But we're going to, at the same time, build up a representation of him. So I'm going to go ahead and I'm going to give myself another function in here. So private string get. Ooh, that's weird. Get matrix as string. All right, this guy's going to create a string answer and start off as the empty string. I'm going to steal this loop here. So we'll go through every element of our matrix, but the matrix should already be filled up. And then what we'll say is we're going to say answer plus equals. Let's do this dot the matrix at bucket I j concatenated with a space for right now. And then we're going to say answer plus equals. Want to give it a couple lines? We'll see how that looks. Think one's plenty? We'll see. If you're wrong, it's a 0 for the day.
All right.
All right, so we go through this guy, and we're just building up this string, and we'll put our carriage return line feed in there, and then in the end, we'll return answer. So then what we'll do down here is we'll set our output labels text to, let's just put the grid in there. This dot get matrix as string. So when we click that button, it'll read in the rows and columns, it'll build a two-dimensional array, convert it to a string, and put it into the output text. Let's see what that guy looks like. So 4 by 5. Generate matrix, row. Let's see. Array index out of bounds. Let's see what we did. We walked off the end of our array somewhere. It's probably a word. I probably have an I where I should have had a J. 0.
Oh yeah, the second for in the J.
Ah, right here. And that, since we copied it from down here, we're going to have the same problem down here. All right, I was testing you and you all failed. It's 2 zeros for the day. Well, potentially. 1 0 so far, but when this thing looks like crap, it's going to be 2 zeros. So 4 by 5.
Yeah, it looks okay.
What do you think?
I think it's
So it looks like crap. All right. So now we're going to go ahead and so what's the idea? We're supposed to randomly, so it's supposed to be mostly filled up with zeros, and then we're going to randomly put in some values.
Yeah.
Okay. So let's go ahead and randomly generate some values in there. So if we have a, so we're either going to do a 0 or something else, and let's do it this way. We're going to give ourselves a global random number generator, just because we're going to probably use that quite a bit. So private random R. It's not going to do it for me. Can you just import it for me?
no.
This dot R is equal to new random, like that. All right, hold on. What's the is that shift return it wants me to do? What's that key? Is that control return?
You can look at your keyboard. Did it? I think it did it. Yeah, see? It doesn't show the.
What is that key? That's just dumb. Okay, fixed. All right. So now we have our random number generator. So let's just take a stab at this and say that there's an 80% chance that the number will be a 0. All right. so we're going to generate a number between 1 and 100, or 0 and 99, let's say. So if r dot next int 100, that gives us a number between 0 and 99. If that guy is less than 20, then we'll say answer plus equals, oh, hold on, I'm sorry. Not going to be in here. This is when we're generating. This is our printout right here. So this guy right here. If that's the case, then instead of a 0, we'll say r dot next int. What is our 500 is our range of values? All right. Else, set it to 0. Okay, so we're going to try to generate a number between 0 and 99. If that number is less than 20, we'll generate a number between 0 and 499. Oh, did I say 1 in 500? Was that the homework? Okay, so that's fine. That's the +1. All right, else, make it a 0. So we're basically saying there's a 20% chance it'll be a non-zero. We'll see if that generates something that looks okay for us. All right, so let's run this again and see what we get. So 4 by 5.
So we should have four space holding. It's not my fault. It's your fault. You should add more space. Make those numbers a single chart.
Let's do this.
Display.
Let's see if it does what I think it should be doing. So what do you think? Is this Android stuff fun or worse?
Plan.
We need more time to get used to it.
Yeah, it's not working.
So I got to do 3 spaces.
You should determine how long it is.
Oh, I have to pad it?
It will not look.
No, I get it. I get it.
You should determine how long it is.
Yeah, and then center it. Ay. This is terrible.
Just add space. Depends on how long.
Let me just try this real quick. So the biggest it can be is 3 digits, right?
Yeah.
So what we can do is we can have a 5-digit placeholder and then pad it on either side. Yeah, it's better, but it's still not right.
At least we know it's not right.
All right, so let's do private string pad. And this guy's going to take in a int number and a int spaces. And let's say we'll do int num spaces is equal to spaces minus the empty string concatenated with number dot length. num spaces, divide equal 2. Then we'll say string answer is equal to the empty string. For int I is equal to 0, I is less than num spaces, I plus plus, answer plus equals space. Then answer plus equals number. Then this guy again. We're going to pad it. That'll put the correct number of spaces on either side of it, is the theory here. And then return answer. Okay. So now when we have our number here, we're going to say answer plus equals, oh, that guy, this dot pad, that number, and let's try 5. See what that looks like. Roll the dice.
Yeah, it's just
Only 20% of the time. Okay, so 5 wasn't good for a triple digit number, so we need to make it 6. Actually, will that work?
I think there's no way.
Yeah, it's still going to be off sometimes.
Yeah, there's no good way.
We're just going to say once it's close, we're going to say it's good.
I would say just add that to one side. Just add that at the end, no pad.
Oh, don't put a pad at the end of it. Just always put one.
Yeah, on one side.
So you want to do it afterwards.
Yeah, I think it looks okay.
All right, so you want to not divide it by 2.
Yeah, just add it.
And you don't want to do it beforehand. You just want to do it afterwards. Okay. Why is there space before? Oh, there's not. There's not for all of them. So now I think we can do it on 5. It'll look good. Or at the very least, this is going to look as good as we're going to make it look. This is the
It's not important.
right. We just need to be able to see it. 4 by 5, generate matrix. Let's just say it's good. All right. So, in any case, we now have our grid that shows up. We now need to have another button that after the matrix has been generated, we should be able to generate the Yale arrays, right? So, let's go ahead and get that guy in there. Into our content. So we should be able to move that up some. And let's see, we probably, since this is a horizontal, this one's horizontal. We actually should be able to make this guy's orientation vertical, and then we should be able to drag this output label into there. And then change the linear layout's gravity. That's not what it's doing. Center, nope. Center horizontally gets me there. so that fills it. So now we have that guy there. So this will generate the matrix. Let's get a second button on there. Can we fit it right next to it maybe? So we go underneath it. All right, we need to give ourselves a horizontal linear layout right here. And then we're going to put that button in there. All right, and then we're going to drag another button in there. Okay. And this button is going to be, the text is going to be generate Yale. Okay. And then we need to get this guy's gravity set to maybe bottom. And then center horizontally. That's that guy. That's weird. Was his height different than the other one? I'm going to call this guy Gen Yale button. Let's look at this. So this guy had height and width as wrap content. This guy has height and width. Oh, hold on. We have a layout margin set for this guy. I think yeah, we want that guy. That was from when I was messing with gravity earlier. Okay, so then this guy, we should be able to now he's centered horizontally, and we're also gonna we suck it to the top. Kind of want this little space here to go away. So we have it. We need to mess with this guy's gravity. Top. No. Fill vertical. Yeah, must not be able to. It's got to be padding. This guy must have padding associated with him. The layout height. Can't I just wrap content? Yeah, there we go. And then this guy, for his height, width, we can wrap content. Match parent for the width. And the height, we can fill parent. good enough, I guess, for this. Why can't we put that guy above? Oh well, I'm not going to mess with it. All right, so now we're going to have our generate Yale. We're going to have 3 different arrays that are going to show up down here, and those arrays are AIA and JA. So let's create text boxes for those guys. So we're going to have a large text view here. This guy will just say A, and we don't need to give him a name. We will go ahead and just give him a width to match parent for now. No, that's not going to work. Let's make it 30. 50. 50 looks good. All right. Then we're going to go ahead and can we copy this guy? Put another one here. And he's going to have a layout width also 50. And this guy's name is what? IA. Okay, there's IA. And then lastly, we'll have another one of these guys. Put it there. He's going to have a width 50, and his content will be JA. All right, so those are going to be those dudes on the screen. And then we need to go ahead and give ourselves text views to either side. All right, so what we need to do, hold on, before I do that, I need to give myself, that's the horizontal linear layout. That's our output label. These guys all live within that horizontal linear layout. They actually need to live, oh wait, no they don't. They live within this vertical linear layout, good. So we're going to then put a horizontal linear layout here that this guy will live in. We're going to have another horizontal linear layout right here. Oh, come on. We're going to put this guy in there. We're going to put this guy in right there. And then we'll have another horizontal linear layout. And these guys all live inside the vertical linear layout, right? Yep. So another horizontal linear layout. With this guy in there. Okay. And they're all in there. But we just need to get they're a little bit too big for their britches. All right, so now let's get that guy set back up. All right, so now that those guys are in horizontal linear layouts, I can drop our answer box into each of those. So we'll have a plain text view. Actually, let's do a large text view. Just the size of the default font. And actually, we can set the width to match parent. That's fine. And then we'll do another one of these. Oh, that guy's width. Thought we had it at 50. Actually, I want to do something here. I think it's 50%. No. That. Set it back to 50. All right. So now we're going to put this large text there, but that landed in the wrong. Yeah, that guy needs to land here. And its width is going to be fill parent, right? I have it in the right place. What's our output label? All right, here's the next guy. That's the A large text. You know what? I'm going to do this. I have a trick. That's that guy. That guy's working nicely. We're gonna dump this guy. We're gonna dump this guy. This guy works well, so we're gonna copy him. And then we're gonna copy him again. And this is IAJA. Okay. There we go. And then let's set the text for these guys. We'll start it off as kind of an empty array looking thing. All right, and this is going to be just a label.
Okay.
No harm, no foul. I taught you that.
Yeah, I copied yours.
I did teach him that. I say that all the time. And before I met him, he couldn't speak anything except Chinese. That's awesome. All right, so there's that. And then this guy is going to be called IA label. All right, and then there's this. And this guy will be called JA label. All right. So let's just run this real quick and make sure this guy's still looking pretty legit. I mean, this actually almost looks like a legitimate app. We haven't even started the algorithm yet. You don't think this looks awesome?
Yeah.
We can release this on the App Store.
Yeah, there are a lot of apps that are in the Google Play, not as good as this one.
This actually is not going to be bad when it's done.
Yeah.
I mean, if you really...
They have the home.
I don't think so.
I don't think so.
All right, so now let's go ahead and start filling this guy up. Let's start off with our A, because that's our easy one, right? Okay, so to get A, we go through and start at the very beginning and walk for each row, for each column. Anytime we see something that's non-zero, add them to A.
Yeah.
Right? Simple enough. So let's start with that. Easy, Japanese?
Easy peasy chocolate squeezy.
Oh, chocolate squeezy. I thought you said Japanese. Blade's going to attack.
Chinese.
All right. So let's go up here and let's give ourselves a couple of private arrays. So private int array, and let's just call this guy A. We'll have a private int array called IA and a private int array called JA. All right, so those are our guys there. And initially, let's give ourselves a function here just called maybe gen A, just to generate the A array. Okay, so we'll have a private void gen A.
By the way, does Java support array? I mean, support push function option array?
No, but we could build a linked list.
Yeah, I know.
So let's start with it simple, because who knows we'll actually finish it or not, but at least this will be a good experience. All right, so public void gen A, and then we'll this guy is going to, let's call it gen A array. All right, and he's going to go through and he's going to capture all of the non-zeros, right? Okay, and then he's going to add him to that array.
Yeah.
Correct? Okay, well, I have an interesting way of doing this. So what I'm going to do is I'm going to have my loop. I'll steal this guy.
Let's see.
Okay. And then we have this closing one here, right?
Mhm.
So this will go through, and what we're going to do here is we're going to have a string answer is equal to the empty string. Every single time I see something that's not a 0, if this dot the matrix at bucket I, j is not equal to 0, then I'm going to say answer plus equals this dot the matrix at bucket I, j, followed by a space. Then I'll say this dot a, what do we call it? Do we just call it a? Yeah. Is equal to answer dot trim dot split on spaces. Let's do it right. Oh, that's going to give me a string array. That's fine.
Yeah.
So we'll string array the nums is equal to that. Then we'll say this dot a is equal to a new integer array of the nums dot length. And then for int I is equal to 0, I is less than this dot a dot length, I plus plus. We'll say this dot a at bucket I is equal to integer dot parse int row. The nums at bucket I. Like that. And then to test that real quick, let's go ahead and give ourselves a function for that button. So public void generate, what do we call it? Generate Yale button clicked. Did we ever write that maybe? Nope, we didn't. That guy will take in a view as a parameter, and what we're going to do right now is we're going to go ahead and we're going to say this dot gen A array. That's the only one we have so far, right? Okay, and then we need to go ahead and convert A to a string. Actually, can an array? Does an array have a toString? I don't think so. It doesn't. So we need to give ourselves another function. Private string array to string, and we'll have this guy take in a int array. AR is a parameter, and we'll go ahead and say string answer is equal to, we'll start off with it looking like this. And then we're going to say for int I is equal to 0, I is less than AR dot length, I plus plus, answer plus equals, and here let's put an extra space there in the front. Answer plus equals AR at bucket I concatenated with a space. And at the very end, we'll say answer plus equals a closing square bracket, and then return answer. So that'll convert any array into a string. So after we gen that array, now we need to output to the label that holds it. So we need to go and give ourselves access to those. I think we named them correctly, didn't we? So this guy is A label, and this is AI label, and this is JA label. So let's give ourselves programmatic access to those. So up here, just like we had these two, just like we have this output label here, we're going to have 2, 3. So this is A label. This is AI label, IA label, and this is JA label. All right, and then we'll give them values in here, so it's going to look a lot like this guy. Give ourselves 3 of them. Actually, let's just give ourselves 1 of them for right now, and then we'll doctor this one. So this guy is A label. And it'll be A label. This is IA label. This is JA label. Row. This is IA label. IA. JA. All right, so now we filled in all our labels. So A label is equal to A label. IA label is equal to IA label. JA label is equal to JA label. So now we have access to those inside of our code. Okay, again, that's MVC. Designed it out in one place, coded it in another place, so we had to connect them. So this is where we just connected those 3 labels so we have access to them. So we'll come down here. And after we generate our Yale button, we'll call gen A array, and then we'll say this dot A label dot set text. And what are we going to set the text to? We're going to set it to this dot array to string this dot A. So we'll go ahead and call upon our function we wrote called array to string, passing it our A array, which was just generated, the line before that, and we'll set the A labels text to that. Okay? And we're going to copy the name of this function so we can set it for the on click of that guy for this button. So generate Yale has an on click. Right, so now that guy will call it. So now we'll want to generate our matrix first. Then we'll go ahead and click generate Yale, and it should fill in just A with all of the guys from it, right? I mean, this could be a top-selling app. I mean, haven't you ever just sat around saying, you know, I wonder what the Yale algorithm would look like for this particular matrix? Not even this one, actually a random matrix. So we'll generate our matrix. Row. Oh, I didn't fill in my rows and columns, and we didn't check against that.
Right.
So I just tried to do an integer.parseInt of nothing.
No.
That's why it crashed. All right, so it crashed for a good reason because we did not do error checking on our text fields. We better put stuff into those boxes is the punchline. So we'll do another 4x5. Now we'll generate our matrix. So this guy should have 3 elements in it, right?
Yeah.
Let's generate that. There's our 3 elements.
Yeah.
So far, so good? Yeah, it looks legit. Well, we could charge easily 99 cents for this as is. All right.
If you pay more, you can unlock more functions.
More functions. You want IA and JA? Yeah. This is $4.99 and this is $49, $9.99, $99. All right, so now let's go ahead and let's generate IA. So let's look at this guy. So IA looks like what? Okay, does IA always start off with a 0?
0, yeah.
Okay, so he's always going to have a 0 in it. So we can go ahead and fill him up with a 0. Now, first of all, how many elements are in IA?
Columns plus 1. No. Rows plus 1.
Rows plus 1.
So number of rows plus 1. So it's this dot the matrix dot length plus 1 number of elements. It's the matrix, that's the number of rows that are in it, right? So let's start off with that. So go back into this. And we're going to write another function here called gen private void gen IA array. Okay. So the very first thing we do is we say this dot IA is equal to a new integer array of size this dot the matrix dot length plus 1. Okay? Then we know this dot IA at bucket 0 is equal to 0. We can hard code that in. Now we need to fill the rest of them, right? So now what we do is we start walking through our array, okay, row by row, finding out the position within the row of the first element, the first non-zero element, right? All right, so we have nothing on this row.
So it's 0.
Okay, so then so far we have a 0. Now we get to this row, we hit the 5. The 5 is at position 0. Right? Is that where the 0 comes from?
The 0 is the first
That's the
row.
difference.
So it's the third number. 2 is the 5.
Ah, 2 is the 5. So this is row 0. This is row 1. This is row 2. This is row. It's not row 3, right?
Actually,
That's the total number.
Yeah.
So we really only have to do everything but the last row.
The last row we still need to add it.
Well, if this is always 0.
We skip it.
Yep. So now this is the position of the first non-zero number where?
We count how many non-zeros
Yeah.
in the first row.
Okay.
Three non-zero numbers.
So we have 0 of
zero.
these.
Yeah, those are
Then
0.
add the second non-zero number.
Second will be 2.
The 2.
And then add one more in the third. One more in the fourth.
It means how many non-zeros.
Okay, so this is 0 because there's 0 in this row.
Yeah.
This is 2, so there's 2 in this
Add
row.
the 2.
Then add
Oh,
one.
plus the 2,
Yeah.
plus 1. Okay, I get it.
And plus 1.
I get it. Okay, so we currently have a running total of 0. So that's what we put into the first place.
Mhm.
So what I really want to do here is have this int running total and start that guy off at 0. And then we're going to go ahead and let's just have a loop for int I is equal to 0. I is less than this dot IA dot length minus 1, right? Because the last element is a hard-coded this dot A dot length, right? Number of elements that are in there. Oh, and then I need to do plus plus. All right. So as we're spinning through here, the very first thing we'll do is we'll set this dot IA at bucket I equal to running total. Right? It's the very first thing we'll do. Now we're going to check the current row, counting how many elements are in each, or how many non-zero elements are in those columns.
Yeah.
Okay? So for int j is equal to 0, j is less than this dot the matrix at bucket I dot length. That's the number of buckets in this row. J plus plus if this dot, the matrix at bucket I, J, is not equal to 0, then running total plus plus.
Then the last matrix.
Right? That'll spin up. It'll go ahead and fill that up with the next value, so on and so forth. Then finally at the end, we'll say this dot IA at bucket this dot IA dot length minus 1 is equal to this dot A dot length. Sound right?
Yeah.
Okay. So this will be gen IA array. So down here, when they where's my function? Generate Yale button clicked. We'll do gen A array. This dot gen IA array. Then we'll set the label for this guy equal to that, and then we'll set. Let's just steal this. Now we can set IA's label. IA label is equal to this dot IA, converted to a string. So go ahead and run this. So we'll do another 4x5, generate matrix, generate Yale. So here's all our values. 0 in this one. Then for row 1, there's 1 non-zero number. Still 1, still 1. Now there's 2. Okay, so is this the correct IA? All right. So, and then let's see. So, actually, hold on. Let's do, this is 0 is the first one anyways. There's 1 in this row. Still 1, still 1. Then it became, shouldn't this guy have 1 extra element in it?
No.
1, 2, 3, 4, 5 there. That's all. Yeah.
All right, so this is 0 by default. Then there's 1 in this row. Still 1. Still 1. Then now it becomes 2. But then don't we tack on this last 2?
No, that's all.
Well, I see that it's the way it's supposed to be, but it's the way I'm generating it. That number is this dot A dot length. So is this dot A dot length the same thing as saying running total?
Yeah.
They're equivalent to each other, right?
Yeah, because.
So I should be able to say running total here because that's what I counted. It should end up being the same.
Run again.
Oh yeah, it should be the same.
This is more correct, the running total thing. Before we had it hard-coded to be the number of elements. This actually should match the number of elements if we counted correctly. So, crashed. We really should put warnings on there. Four by 5. Generate matrix. There's that. Yeah, so we have 0, 1 in this row, still 1. Now we have 2. Now we have 3. Yep. So that last guy is not necessarily the length of this. It will end up being the length of that, but it's because of our running total, how our running total worked. Okay, so that's IA. Lastly, we have JA. So let's look at JA. How is JA calculated? This is the column of the first. So the 5 lives at bucket 0 of its row. The 8 lives at bucket 1 of its row. The 3 lives at bucket 2 of its row. and the 6 lives at bucket 1 of its row. So we need to go through each of these guys and find out where they live positionally in their row.
Yeah.
Okay. Do we know what row they're in?
From oh, but we don't need to know that.
We don't know exactly.
Doesn't IA tell us?
You can.
IA tells us that we will find 0 in the first row.
But it's more complicated.
Yeah.
It says we'll find the next 2 in the next row.
Yeah.
So we know which row to look in, right?
The I value changes, that means there is a new number. If it doesn't change, that means all the rows.
Yep. So as we're going along, we know where the next number is, and every single time we move through here, that next number becomes 1 bigger.
Yeah.
Okay? So we're really going to start right here in that array in IA and ask how many numbers from A are in, how many well, it'll be how many numbers from A are in this row. Since it's 0, we're going to move down to the next line, next row. Then we'll ask how many numbers from A are in this row, keeping track of that our current index in A is 0. So current pos in A is 0. All right, so let's start writing some of this. So we'll do a private void genJA array. We'll say int cur apos is equal to 0. That's our current position in A. In fact, let's current pos in A is equal to 0. All right. How many elements are in JA? Same as A. Okay. We'll say this dot JA is equal to a new integer array of this dot A dot length. All right. Now we're going to start spinning through IA starting at bucket 1. So for int I is equal to 1, I is less than this dot IA dot length, I plus plus. Okay, we know that we are currently in we're currently in row I minus 1. That's the row we're in. Okay, so the thing we're going to ask here is how many non-zero elements are in row I minus 1? That's what we're asking here. Okay, the answer to that is what? This dot IA at bucket I.
No,
Might be.
Yep.
You have to subtract the 1 from the 1.
This dot IA at bucket 1. That's the number of non-zero elements that are in row 0 of this guy.
But don't we have to subtract it from the 1 before?
No, not yet. All we're doing is we're asking us how many guys we have.
Just do IA plus 1 minus
Yeah, plus 1 minus.
the bucket I.
That's how I did it too.
Okay, so you did what? You said this guy minus this guy?
No, the opposite.
No.
You said this guy minus this guy. That gives us our 0.
Yeah.
Then this guy minus this guy gives us how many are in the next row.
2.
Okay, got it. So the number of guys we're going to find in there. So let's give ourselves a int num in this row. Num in this row is equal to this dot IA at bucket I minus this dot IA at bucket I minus 1.
Yeah.
Okay, so that's how many elements we need to grab from this, right? So we're going to now search the current row for the for the next num in row elements from A. So we're gonna search for positions. Let's say column positions. So for int j is equal to Cur pos in A. J is less than cur pos in A plus num in this row. J plus plus. So we're going to advance by this many, but we're starting from this position, right? Okay. So this is going to go through A, and we're going to look at the element in A at position J. And we want to find out where is he located in row I minus 1. All right. So we're going to create a little private. So private int find pos in row of a number. So the number we're looking for, and then the row we're looking in. For int I is equal to 0, I is less than this dot the matrix at bucket row dot length if this dot the matrix at bucket row bucket I for the column is equal to num return I, the column it's in. Okay, we know we'll find it, so we can say return -1 here is our catch-all, but we'll never actually hit this line. So I'm calling this function whenever I need to find this number in this row, and I'm interested in what is the index, what is the position of that number in that row. So I'm going to go through all the elements in that row, all the column i's in that row. As soon as I find a match for the row and the corresponding column, I'll return the column he was in. Okay, so that's what find pos in row does for me. So down here, we're going to search for our column position. So we're going to say this dot cur pos in A. This is going to be our, that'll always be J, right? Yep. So we'll say this dot JA at position J is equal to this dot find pos in row. What number are we looking for? This dot A at bucket J in column, in row I minus 1. That should find our number. So this is going to go through all of the columns in A, starting at cur pos in A, all the way up until the number of elements in this row. And for each of those elements, which already live in A, we're going to look for that element in the current row, find its position, and store it at the next position in JA. All right, so that should generate JA. This dot gen JA array. And then this dot JA label, JA. Is this the matrix number? Oh, I plus plus. Okay. Run this. So we'll do another 4x5. Generate matrix, generate Yale. Ooh. Well, that was our -1 that we got from it. Why is that? Well, we should get a 0. The position of this value lives at index 0 in that row. So there is one element in IA, or one element in row 0. Which element is it? It's 179. Let's go and look for it in, okay, so that's this guy right here. All right, so do we have a special case for when it's row 0? Okay, so JA will be the same length as A. Fine, we're good there. Number of elements in this row is going to be calculated right here. Let's, show line numbers. Big fan. Right. Do we have a... How do I get my... How do I get a breakpoint on here? Oh, just click. Nailed it. All right, let's turn that one off. We'll put it here. All right, now we'll do a debugger. Can't open the debugger. All right, well, that's a weird bug. It's probably some security setting thing I have to screw with. All right, so we're going to walk through it then. So let's print out. I'll show you something you can do here in Android because it's a little bit wonky. So after we get the number, the num in this row, it's the number of elements in this row. The very first one, it should be this dot IA at I, which is 1. So this dot IA at bucket I. In this case, that would be 0 minus -1. That's going to be 0.
Yes.
So we're not going to find any in that row. So then we're going to say start off at bucket 0. That's where cur pos and A started at. Keep going as long as J is less than 0 plus 0. So is J less than that? It's not, so we'll fail right there. Oh, but don't we still need to set a value in JA? No, we don't, because we haven't hit the value yet. We're fine. We're good. Spin back up. So now we're at row 1, so value 2. So now we're sitting right here at the number 2. All right. So 2 minus 0 is 2. We're still at 0 for cur, pos, and A. So J will start off at 0. Keep going as long as J is less than 0 plus 2. So it should be 0 and 1. J plus plus each time. Fine. Then we'll say this dot JA at bucket J. Yeah, so this will be 0 because that's current pos in A, is equal to this dot find pos in row of this dot A at bucket J. So this will be the very first element in A, as well as the row we're looking in, which would be I minus 1. So in this case, that would be row 1. This guy right here, right? So I'm passing in, so this is 0, 1, 2, minus 1 gives me the row I'm looking at. So I should be looking in the matrix at row, and then all the columns in there. Okay, well that looks like it should work. So then we're going to look for num at row. So I equals 0, I is less than the matrix at row dot length, I plus plus, if the matrix at position row I is equivalent to the number we're looking for, then return I, the index in that row. If we get through this entire thing and never find him, which should never happen, because we should always look for the guy in the place where he's supposed to be. All right, so let's do this. I'm going to do a log.I. Searching for num in row. So this is this is equivalent to system.out.println. It writes something out to something called logcat, which we'll look at here in a second. But let's just go ahead and run this guy.
What does it mean by star?
This, it makes you tag it. So I'm gonna, instead of it showing, I'm gonna see a whole bunch of crap down here. This will be my way of pulling it out.
But
From-
why there is
I just put him in there. I could make this say elephant if I wanted to. That's just gonna help me be able to pull it out of the crowd. Okay, so we'll do 4 by 5, generate matrix, generate Yale. Actually, this is interesting. So we got 1 1 1 0 0 0 0.
Let's see how you are lost.
All right, so the very first one we should look for is what? We should be looking for the number 315 in row 0.
Yeah.
So I looked for the number 315 in row 0, but then I looked for it again in row 1.
Okay, something wrong with you.
Then I looked for it again in row 2. Again in row 3. Okay, so this says we're always looking for the same J. So somewhere in, oh, I know the problem. Kerpos and A never changes.
You say plus.
That needs to happen. Every time through here, Kerpos and A needs to become bigger than it used to be as we're traversing down A.
I think it's sometimes exit.
All right, array index out of bounds exception. Okay. So J equals Kerpos. Keep going as long as J is less than Kerpos in A.
You should say if they find something, they will
Well, we'll always find it here, but in this case, we are going through that array one more time for the next row. So we need to say if curpos in A is less than this dot A dot length and that. So we need to make sure that curpos in A is currently a legal position. Otherwise, we'll walk off the end. Because in that last example there, I didn't keep it, but I think our last row didn't have numbers in it. So right now it mostly works. We just have some special cases where it's failing because we're walking off the arrays. 4 by 5, generate matrix, generate Yale. All right, so we have 1, 2, 4. That one was kind of an easy one. So let's generate this one again. All right, so we should be looking for 454 in row 2. No. Yeah. I'm just saying we should be looking for this number in row 2. That's the first thing we should see over here. We should be looking for this number in row 3. And so let's see where we're looking for that 30. We're looking for it in row 2. Why are we looking for it in row 2? Are the other ones right? So these are our 2 numbers. So 0. So there's nothing in the first row, nothing in the second row, 1 in the third row, another 1 in the fourth row. Yeah, I mean the -1 is correct because we're looking for it here in this row, which means we're never actually going to the So the thing that broke that was the last thing we just put in there, which was this and. If curpos in A is less than this dot A dot length, J. J is less than this dot A dot length. Curpos is changing in here, right? Curpos is changing. This happens one time. We know we're going to go through the correct number of times here. We just need to make sure that we're allowed to even start. All right. Four, 5, generate matrix. Oh, yay. That's a lot of -1s. Okay. So we should be looking for, well, it found that.
Yeah.
We should be looking for 39 in row 1.
It means just keep on searching for this in the first row. It never searching the second row.
Why?
Keep on searching.
All right, hold on. We gotta look at row. I minus 1. I starts off at 1. Keep going as long as it's less than IA dot length. I plus plus. So it should go through every element of IA. Fine. This should always be the row we're currently looking for. So the number of elements in this row is going to be this dot IA at I minus this dot IA at I minus 1. I think that's going to be correct. we could actually do a log. Well, curpos in A, J is less than this dot A, J is less than curpos A. I'm going to say this dot JA is going to be equal to this dot find pos in row, this dot AJ, and I minus 1. So if we're going through all the elements of IA here, the very first time through this, num in this row is going to be 1 minus 0, which is 1. Right? 1 minus 0, which is 1. So we're going to start J off at curpos in A, which is 0. Keep going as long as J is less than A's length, which it is. And J is less than curpos in A. Oh. We can't do it off that. This number is changing.
Keep on changing.
This number is constantly changing, so we need to just do this. Int max index is equal to curpos in A plus num in this row, and just say less than max index. So we broke that when we incremented curpos in A.
Find what's the row and name of the exit.
Okay. Four, 5, generate matrix. 1, 2, 3, 1. So this is at 1, 2, 3, 1.
Yes.
Woot. All right. Generate another matrix. 0, 0, 4, 2.
Yes.
And look at this powerhouse of an app. Sick. 3, 0, 3, 1, 2. Seems to be doing it. All right. Now, last piece. Let's see if we can figure out this real quick. I'm going to create a new repository. We're going to call it Yale Algorithm Android. Create that. Copy this guy here. And let's see if it has a decent source control dealy thingy. Enable version control integration. Let's go with that. Version control system. Git. All right, so far so good.
So how you lose?
And then go back in here. Let's commit changes. Okay, nothing to commit because it just created it to begin with. All right, so now let's import into version control. create Git repository, import into share project on GitHub. Okay, well, I'm just wondering if it's the right one. I wonder if this is going to use the gist thing, though. That's my concern. Guess we'll find out here in a second. Well, it wants to know if I want to create a new repository name. Well, let's do that for right now. So it actually generates the brand new repository for us on there. Yeah, here's the Yale simulator. But I was hoping, well, I mean, it doesn't matter at this point, but let's just take another minute here. Oh, I might not be able to do it now because I've already pushed it. So now it's like linked to that repository. So I guess whatever. So let me do this just so you guys can download this app to use it as kind of a source for your homework assignment.
So basically everything is the same except for the buttons
For what?
in this Android program.
Everything is the same as what?
I mean, like Java now, the Yale algorithm that you have written.
Oh, yeah.
Everything
Yeah, everything's the same.
except for the buttons that you
Yep.
have to.
Yeah, I mean, it's a button that we click to make it run instead of saying to do it from...
So we can first run the program in the Eclipse and then...
well, I mean, if you wanted to, you could write the algorithm side in Eclipse. But I mean, I guess I don't think I would do that, but I mean, whatever makes you happy is fine. I mean, they're the same tool. So your homework assignment for next time it's up, you can go and read the, it has you look at hashing algorithms. In fact, here, I'm just going to go here to this guy. Bloom filters. So a Bloom filter is a type of probabilistic determination engine, which is a really scary way of saying I have a giant set of data, okay, and the giant set of data is too big to effectively search for a value. So do we have a way of making a guess as to whether a value is likely in this set of data? Okay? So this uses, so I give you a couple of different things that I want you to read. So this uses the idea of what's called a hash function. A hash function is a one-way cipher, which is a scary way of saying it takes any size input. Okay? It's a function that takes any size input and always spits out a fixed size output. Okay? So if I could send an infinite number of things into a hash function, and it will always come out as the same size thing. A famous hashing algorithm is called MD5. You may have seen it on its Message Digest 5, and it's used for determining whether or not when you download like a 5 or 6 gigabyte file, to determine whether or not there was a corruption or something like that. But you could take a 5 or 6 gigabyte input, and it'll produce like a 40 character string. That's the output of a hash function on a 5 gigabyte file. All right? So hash functions are guaranteed to have a certain size, but we have something called collisions. So if you take every file that's ever existed in the world and we hash it, okay, and we hash each of those files individually to the same fixed size output, there's possibly going to be 2 files that hash to the exact same output value, right? That's possible because the output's fixed. Okay, so what the a Bloom filter does is it uses a very simple hashing algorithm. The hashing algorithm isn't all that important of this. It's just a rotation. When you look at it, it sounds scary. What's the name of the hashing algorithm I told you to look at? Well, Bloom's the filter. There's a hashing algorithm I reference in there. But whatever, he's looking it up right now. But punchline is, it sounds like it would be really scary. All it is take this input and rotate all the characters by like 10 characters in the alphabet, something like that.
Murmur hash.
Murmur hash. Okay, so sounds like it would be scary. All you're doing is you're taking an input and you're converting it into a separate value, a different value that is the hash value. But that hash value is not overly complex. All right? And then what a Bloom filter does is it essentially creates this array. And based on what you have in this array, you're able to then say, given this value and given its hash value, is this value likely in my gigantic collection? You're passing the hash value of the value you're looking for through the Bloom filter to determine whether it's likely in your collection. Okay? So it'll be kind of along the lines of what you had for your homework assignment today in terms of complexity. It's really just a matter of writing the stupid little hash thing, which is not going to be overly difficult, and then creating this array and then checking elements against the array. But in order to do it, you're going to have to first randomly generate a bunch of elements that are going to be in your set. So you can generate 10,000 numbers, let's say, convert them to strings, hash them. They'll go into this your Bloom filter. They'll go into your data set, and then your Bloom filter is kind of a representation of your data set that you can then pass all your questions through and say, is this value likely in my gigantic data set over there? And the Bloom filter itself can answer that question rather than you having to go check the data. All right? So that's kind of the introduction to it, but the homework assignment is to implement a Bloom filter similar to, I give you a website on there that has a little tool that you can kind of test it and see how it works. You can put in 5 or 6 different pieces of information and make an app that essentially does that. Make sense? All right. So this guy is up. I posted it in Slack. I assume everybody has access to Slack now. All right. So you have the access to the GitHub. Maybe a good starting point would be download our app here, get it working, and make sure you understand it. But you can at least use that as a starting point. Either start with that app or use that app as your model for making sure the buttons work and stuff like that, so you can kind of see how we wrote the different pieces. Sound good? All right. I will see everybody next week. Have a happy Thanksgiving.